First of all, we're asked to write down and simplify the general term in the expansion of 2x minus 1 over x squared to the power of 9. So this is the general term in the binomial theorem. Because it's to the power of 9, it's 9 choose r, times first thing in the brackets is 2x, so 2x to the 9 minus r, times the second thing in brackets, the minus 1 over x squared, to the r. So that's 9 choose r. Now 2x in brackets to the power 9 minus r, we can split, and we can make this 2 to the 9 minus r times x to the 9 minus r. Minus 1 over x squared, we can split this as well and make this minus 1 times x to the minus 2, all to the power of r. So we can then split that and make it minus 1 to the r times x to the minus 2 to the r, which is 9 choose r times 2 to the 9 minus r. We'll rearrange the order so that the x's are at the end, and this will be times minus 1 to the r, and then x to the 9 minus r, and this is x to the minus 2r. We add the indices, 9 minus r plus negative 2r is 9 minus 3r. So this last term is x to the 9 minus 3r. So this is the general term. We're then asked to obtain the term independent of x. Now the term in this expansion, independent of x, means that there will be no x term, or that the x will be to the power of 0. We'll find that term by setting the 9 minus 3r equal to 0. 9 minus 3r equal to 0 gives us that r is equal to 3. So the term we're looking for is the term with r equal to 3. So that's 9 choose 3 times 2 to the 9 minus 3, which is 2 to the power 6, times minus 1 to the power of 3. And this last term, x to the 9 minus 3r, when r is 3, this will just be x to the 0. Nine choose 3 is 84, times 2 to the power of 6, which is 64, times minus 1 to the power of 3, which is minus 1, and x to the 0 is just 1. So multiplying this gives us our term independent of x, negative 5376. We're asked to find the equation of the plane passing through these 3 points. First thing we do is we find any two vectors lying on the plane. So we could find first of all P to Q. Now P to Q will be given by position vector Q minus position vector P. Position vector of Q is 1, 2, 3. So that's 1, 2, 3 minus position vector P minus 2, 1, minus 1. So this gives us 3, 1, 4. So this is one vector lying on the plane. Another vector lying on the plane would be P to R. And to do that we work out position vector R minus position vector P. So that's 3, 0, 1 minus minus 2, 1, minus 1, which gives us 5, negative 1, 2. So this is another vector lying on the plane. We can now find a normal to the plane by forming the vector product of these two vectors, PQ cross PR. So this will give us a normal to the plane. To do PQ cross PR, we first of all write down I, j and k, and then each of these two vectors in turn. 3, 1, 4 followed by 5, negative 1, 2. We now do another copy of these three vectors. To form vector product, we form the three down diagonals. We form the three up diagonals. To work this out, to get the answer to PQ cross PR, we form two brackets separated by a minus. Into the first bracket we're going to put the answers in terms of I, j and k of the three down diagonals. I times 1 times 2 gives us 2i. The j is going to come from this diagonal. 5 times j times 4 plus 20j. The k is going to come from the middle. 3 times minus 1 times k minus 3k. In the second bracket we're going to put the answers to the three up diagonals multiplied. The I is going to come from the middle one. 4 times minus 1 times I minus 4i. The j from the third one. 2 times j times 3 plus 6j. And the k from the first. K times 1 times 5 plus 5k. I'm going to now take the brackets away from the first and the second to simplify. We have to be careful taking the brackets away. In the second case there's a minus outside, so we have to apply that minus sign to each of the terms inside. 2i minus minus 4i is going to give us a plus 4i, so that's 6i. 20j minus plus 6j, that will give us 14j. Minus 3k and then minus 5k will be minus 8k. So this tells us that a normal to the plane would be 6, 14, negative 8. We can simplify this normal and still have a normal by dividing all through by 2. So we'll do that. Dividing by 2 gives us a normal 3, 7, negative 4. So we now work out the equation of the plane by dotting n dot r and making that equal to n dot with one of the 3 points P, Q or R. I've chosen Q. R is a general point x, y, z, and n is our normal 3, 7, negative 4. So that's 3, 7, negative 4 dotted with x, y, z, and that will be equal to the normal 3, 7, negative 4 dotted with the vector q representing the point q, 1, 2, 3. So that's 3 times x, 3x, plus 7y, minus 4z, and that would be equal to 3 times 1, plus 7 times 2 is 14, minus 12. 3x plus 7y minus 4z is equal to 5, and that's the equation of the plane that we're after. We're asked to write down the Maclaurin expansion of e to the x as far as the term in x cubed first of all. And you should know this, that e to the x is 1 plus x squared over 2 factorial, which is just 2, plus x cubed over 3 factorial. 3 factorial, 3 times 2 is 6 in the bottom, so that's plus x cubed over 6. The second bit of the question says, hence or otherwise obtain the Maclaurin expansion of 1 plus e to the x all squared. 1 plus e to the x. Then we want to square it. Now 1 plus e to the x is just 1 plus this expansion here. So that's 1 plus 1 plus x squared over 2 plus x cubed over 6. I want to square this. The 1 plus the 1 at the start gives us 2. So this is 2 plus x squared over 2 plus x cubed over 6. And we want to multiply this by itself because it's squared. Now to multiply this out, we only want to consider the terms which are going to give us no higher than x cubed. So we start off by multiplying 2 by the whole of the second bracket. So that's 2 times 2 plus x squared over 2 plus x cubed over 6. We then move on to the second term in the first bracket, the x. Now, we won't multiply by every term, since if we multiplied x times the last term, that would give us an x to the 4, and we only want to go as far as x cubed, so only the first 3 terms in the second bracket will be considered. So that's x times 2 plus x squared over 2. Then moving on to the next term in the first bracket, the x squared over 2, we will multiply that only by the first 2 terms in the second bracket. Again, because if we go any further, we'll have powers higher than x cubed. So that's going to be x squared over 2 times 2 plus x. And finally, moving on to the x cubed over 6, we will only multiply the first term in the second bracket. Again, because if we multiply further, we'll get higher than x cubed powers. So that is x cubed over 6 just times the 2. Multiplying out the first bracket, 2 times 2 is 4, 2 times x is 2x, 2 times x squared over 2, the 2's cancel, so that's just x squared. 2 times x cubed over 6, the 2 cancels into the 6 to leave us 1/3 x cubed. Now multiplying out the second bracket, x times 2 is 2x, x times x is x squared, x times x squared over 2 is 1/2 x cubed. And I'm writing corresponding terms directly underneath each other. Moving on to the third bracket, x squared over 2 times 2, the 2's cancel, that just gives us x squared. X squared over 2 times x gives us 1/2 x cubed. And finally, x cubed over 6 times 2, the 2 and the 6 cancel to leave us 1/3 x cubed. So we're going to add all of these up, and that will give us the required expansion. Four is just on its own, so we start off with 4. Then we've got 2x plus 2x, it's 4x, x squared plus x squared plus x squared, 3x squared. And finally, we've got a 1/3 x cubed at the top and the bottom, so that's 2/3 x cubed. We've also got a 1/2 x cubed plus another 1/2 x cubed. These two give us 1 x cubed plus a third, 1 and 1/3, and another third, 1 and 2/3, or 5/3 x cubed. And this is our expansion, our Maclaurin expansion.